What's up, everyone? Trust you guys are doing very good out there. This is Texan, and in this video I'll be explaining how to do PCB design, which is very simple and interesting. So let's get started. This is the software, as you can see it here, EasyEDA. If you don't have it, just go to Google and type it. The same spelling, EasyEDA. It's a free software. You don't need to make any payment. We have the online version and we have the offline version. The one I'm using now is full offline. As you can see it here, it's full offline. Exactly, it's full offline. So this is what the interface will look like when you open it. I will try as much as possible to break this video very simple as much as possible. Okay, so let's get started. So like every other software, the first thing is the project, whichever name you want to give to it. One good thing about this very software is you can even watch tutorial and from it has a lot of plugin and the rest, but let me look it from the perspective of a chronic beginner, because I started learning this software just less than a week, and at least to some reasonable extent after I, so that's why I decided to make this video to a beginner. So click on the project, new project, whichever name you decide to give it. So let's say trial, or let's give it trial 001. Let's call it that. If you want to have a description, let me give that name, maybe something like boost pedal. So let's say we want to create a boost pedal, and I want to give it a name, a description of this will boost the boost the volume of our guitar. So let's say that's just a description, so that anybody that see the site and the schematic can really understand what it's about. Then you come here, whichever location you want to put it. I can leave it at my default, so you click save. It will save, then it will open up exactly now. Then if you look at this area, this is all project based on different work you've done in the past. You can see them here. This is where you are working currently, so this is what it will look like. Then this is what we call common library. These are the area where you pick various components like resistor, capacitor, diode, different thing, whatever thing you need. Trust me, you see them here. Okay, so this is under the common library. I'm trying to break it down because when I was learning I did not even see it simple this way. All right, so this is where you see the common library. This is project design. So this is where we'll be working, but when we want to pick components, will come right here. Okay, so let's start project design. So you come to our schematic. By default we don't have any drawing, so this is what this area will look like. Let me zoom it out a bit so you can see it. Okay, now to move it right, what I simply press is my what's it so called, my mouse. Then I will press the shift button. If I press shift, it will move this way. If I press alt, it will move upward. If I press control, you see it now. So if I press that shift and I scroll up, it will move to this side. If I scroll down, it will move to the other side while holding down the shift. Do you understand the shortcut now? Hold your shift down, scroll up, it will move to the side, scroll down, to move to the other way. If I press alt now, if I scroll up, you can see it's down. If I scroll down, you see it now. That can be very handy and very helpful. So in case you want to give it a name, this is your schematic. You can come here, right click on it and rename it to whatever you want to call it. So let's say volume boost. So that's the name we want to give it, and it's there already. So if you want to add the date, every other thing, you can do it. But to save time, that is not where we are going. So let's go to the major business. In case you want to change your paper side, because some of you may decide to print it in paper, but I don't usually print it. I like once I run my PCB design here, then I can print it from GLC into real PCB. You understand? So that's the way I work with it. So in case you want to print it out and maybe it's on A4, whichever paper you want, you can choose it here. All right, so let's get into it now. Let's start the main business. Yep. Okay, so our project is starting. So now the component you want to work will really determine. So let me start with the first component I want. I want a transistor. Actually, in this video, my schematic may not be 100% of what I want to build right now, but I will try to use various components so that you understand the way it really work. I believe you understand now, all right? You fully understand it. So I need a transistor. I will be using just a transistor, 2 film capacitor and resistor and the rest. So let's start with a transistor. Now, for you to have the idea of the transistor you are dealing with, because we have SMD, we have some film capacitor, and we have what's this so called ceramic capacitor, yes, which are the electrolytic type. You can get any type you want, you understand. This video will be very, very detailed. So this is under the schematic. So to see what it looks like, I click on the PCB, and if you move down, you can see. So this is to tell you this is SMD family. Understand now? And these are MPN. You can see the name MPN. If you come here, these are PNP transistor. Why this side is for MOSFET. You understand? So if what you are looking for is not here, you can go and choose it somewhere else, which is you come to this side here, which is component. You click on it. You go to the transistor. Once you go there, it will load up. Although I'm not connected to internet, if I'm connected, it will be very, very fast. But offline, I can still see some of them. You understand? So you see a lot of transistors here. You can see various types. You see them. So, or you come here, you type a specific transistor you want, and that's it. So let's say this is the one I want now. Or let me say this is what I want. I just need to click on this place, and I will click on it to show. You see it now, it's showing there. Okay, very, very simple. So maybe we'll work with this one. If it is this one I want to, I just need to click on it. Once you click on it, click to come there. That is for MOSFET. If it is for PNP, click on it. You see it's showing. If it is for MPN, if I click on it, you see it's showing. Okay. And to let go of it, just click on escape. It will go. So let's delete this, and so whichever one you want, just know what you want and go with it. So for now, let's just keep this very, very simple. So let's say this is a transistor we want, which is Q1. Just double tap on it. You can rename it. So let me assume it's 2N39. That is 3904. So let's assume that is what I want. This is just for practice purpose anyway. So this is 2N3904. Then I need a resistor. You can come there and pick resistor, but at the same time, you have the shortcut to some of this stuff here. So if you move here, you'll see it resistor written on it. If you go down, we have capacitor, inductor, diode. So let's say I need a resistor. I can click it out. I need a capacitor. I can click it out. I need another. I need two three. Two. So that's 3 now. Okay. So to this side, so all these capacitor are film capacitor, which has 100 nanofarad. So let's say you want to change the value, you have the right to do that, which is very, very simple to do. Let me delete this error. Okay. It's not what we want. This is a glitch. All right. So I wanted to click a capacitor. So press escape to let go. Now, for the value of the capacitor, if you look at it, this is 100 nanofarad. So assume this is not what you want. Once you click on it, you can go and change the value there. You understand? You can see the value here. So you can change it to whatever value you want. You understand? For the resistor, same thing. Click on it. If I click on resistor now, you can see the value showing here, 10K. So whichever K you want, just put a value there. That's all. So now let's put our film capacitor here. Don't worry, in this video, we'll still convert it to PCB. See what it will look like. So this is my film capacitor around this side here. Let me put it somewhere close here. I don't want the right up to cover each other. Okay. So I'm giving it space so you can see it clearly. Then come to this place. This is wire. You understand? This is wire. Click on it. Tap on the edge. Move to where you want to click. True. That's very, very simple. Then come to this place. I need a capacitor here. and I need to join it with this place, so I can easily join it here. You can see it very, very simple. Then I need 1 mega ohm resistor for this side. I'm coming, these two resistors are overlapping. Okay, so I need a 10 mega ohm, so that means I will change this value to 10 mega ohm. That is 10 coming. That is 10 mega. You can see it now. There is a mistake at the front there. So there is 10 mega ohms. So we are good to go with this one. So I'm using this to link and to rotate. Just now click on the particular component, tap your space bar. You can see it. If I retap it again, it will rotate. If I retap, you can see it's very, very simple, like ABC. So I want it to be this way, because what I want to do is I want to link the middle with this other side. You understand? So click on your wire. So once you have your schematic, maybe you have something you've sketched out on paper, or a circuit you've been working on before, but you want to learn how to convert it to PCB. So just follow the same process and do your own circuit. It will give you what you want. As you can see, it's connected. So this is for this side. Then this is the part that will be going to my ground. This is my input, so to say. So I can come here and just write just something that I can use to easily identify this place. Let's just write a text. So anything you want, you can get. So let's say this is the text. So let's call this input. Input. And we'll come here, we'll put it. So this is where our input will come through. No, this is my input rather, sorry. This is my output here. This is my output. This is output. Output, okay. This should be C. Let me use C1815 transistor. All right, so that is a transistor we are using. Sorry, it's a simple volume boost. So this is where our input will come through. This is the output. Then this is a part going to the ground. So if you go to this place VC, this indicates the voltage. So based on what you want, I need a ground. So my ground can be somewhere around there. And for my ground, I need to filter out some high frequencies. So let me rotate this, press the space bar to rotate. Come here. Okay, let me rotate it the other way. So I want it to join to this place. Now it's connected. Let's see. Yes, it's connected. Now I need another resistor. Yes, so let's go and pick a resistor. We need a resistor. So let's say something like 1K. Yeah, 1K will do. Come in. Let me click this and change it to 1K. 1K resistor is okay for me. Okay, this is 1K right here. So what we want to do is, oh, seems I have double of that. Let me come again. I've clicked that 2 times, that's why. So just click once, escape, click on that key, change the value to whatever you want. So I want a 1K resistor. So it now, very simple. Then from there, I want to attach this to this. Let me remove this. Onto, so you don't mix things up, okay? That's the film capacitor. So let's rotate this one. See it, it's done already. Connected to this, let's see, it's locked. All right. So this is the one that will now be coming to our ground. Understand that this is the ground. In case you want to use wire, or you can see, just touch it. So you don't need dragging, just click the place you are going. Let me do it again. Just click the starting point and the next place you are going. So you don't need to be dragging it while going. Let's say I'm going here now, you can see. If I click on it, it will get there. Let me control Z. Let me delete it back. First I have to escape. Okay. So let me join it back. So now we have the ground connected to that point. Let's put this to the middle. I believe you are getting value from this tutorial. It is helpful. So you like and subscribe for more. So this is my major input. This is my output. We need to connect a power source. Yes, that is a battery, which will be a 12-volt battery. So come here, VC. This is it, voltage source. So I can put my voltage source here anywhere you want, depending on how you want it. So let me write maybe 12 volt, 12V now. Understand? So that is our major voltage input, and we want to connect that to a 10K resistor. So I can put my resistor here. It's 10K. Yeah, luckily it's still 10K. So connect this together. It's connected. Then from that resistor, we are sending it to the middle point. You understand? So I can put my wire here now and come and touch this. Good. But that's too close to the resistor. I want it to be very neat, especially for those that are just starting. All right. So let's see. It's good. So this is where the power source is. So either 12 volt adapter, or you use battery, or 9 volt, it will still power it up. Okay. So this is our battery source. This is where our audio input is coming, our output. Then this is a ground connection. So this is what the circuit looks like. It's very, very simple and basic. So if you follow this process sincerely, irrespective of the kind of circuit you want to create, get it. You understand? I've explained how to get some more advanced what's it so called, IC and the rest. So if I go to logic, for example, let's say I need a specific IC, just let it load. If you have data, you can search online, or you use the online version. Let's say this is what I want. Just click on place to come there now. So let's assume I want to connect this to my circuit. Actually, it's not part, but let's assume all I need to do is just to wire it the way I want. Let's say this is coming here. You can easily come there. We'll connect it. Understand now? So depending on what you want, but this is not part of what we want to do. Okay, so don't worry, I will still do more advanced video. I'll be very, very advanced, but for now, this is what we want to work on. So this is what our schematic looks like. Then let's now convert it to PCB. But before you go for PCB, always check, do DRC check. So what the DRC check simply means, it will help you check in case, it's possible you try to connect the wire, but unfortunately, it may not touch it completely. So at that point, there will be a loop, there will be a break. And if you don't know on time, if you proceed to print that PCB, you'll be wondering it's not working because there is a short somewhere. Understand? So let's check it now. Go to the design, click on check DRC to scan everything. Now if you look at what this one is saying, error, do we have any error? 0, no error. What is only warning us is that in 395, let me click on it, this specific one that is not connected to anything. Yes, this one, this is the way we want it, because this is where we'll connect to our output jack. So that is normal. But the other one is notifying us about this. That is no error. We are aware of that. Why this side is to our ground, we are aware of that too. You understand? So this is used. This is correct too. You understand? But if you see anything like error here, that means there is a loop or a break somewhere. You understand? So then let's see this. Found some component pin suggesting no connect flag. So C4. Let's check that. C4. Let's see. Pin C4. Okay, it's referring to this terminal. That is still where we want to connect to our output. So we don't have any loop, so we are good to go. All right, let's proceed further now. So our DRC check, it will really help us. But assuming there is any break, you see it will tell you on time. You will know that there is a problem somewhere. Okay, so that is for the DRC. So now let's now convert it to PCB. So all you need to do is come to this design, click on it, click on update/convert schematic. Very, very simple. Click on it. Boom. To load up. And hola. We're almost there. Wait for it. It's trying to tell you that cross-check everything in case there is any mistake or the other. So check it. All the components I want to use are there. So we just click on apply changes. So this is what it looks like. I know some of you are wondering why is everything scattered this way. Don't worry, we'll arrange it. Okay. So all you need to do is this. Our R3 is not connected. Why? Let's check back. Let's go back to our schematic. We made a mistake there. R3, where is it? It's not connected to something. I'm coming. Okay, if I move it, it ought to move with the rest. Let me see. This one is moving good. This is good. Yeah, good. So R3 is not connected. We have an issue. There is a loop. So that is a loop I'm saying. So you have to check it out. Go to your wire. R3, reconnect it. This is where it's going. So let's see if that will save us. Let's refresh it. Yeah, it's connected now. But we need it to be connected to our terminal. There's a loop here too. So click on that wire. Connect from this place to this. Understand? That will save us. Update it. Alright, that should save us now. Good. We're good to go. So it's this part that is going to that 12-volt input. Don't worry, you still understand it furthermore. Alright, so let's go now. So this is what our PCB look like. Don't worry, I know it's still boring. So put this one here. You can now arrange it to the way you want. And in the process of arranging it, it's good you understand the way some of these components work. Like for example, transistor by default they get hot, so you want to give it a space so that it will not affect other components. So put that into consideration. Not just all about you want to manage space alone. No, consider the nature of those components. So this is my C3. I can put this here and put my label here. And this is R2. So let's click on this. We can put it. So you can see this is our schematic. Very, very simple, like ABC. Now let's go back to what our major schematic looks like. Now for here, our R2 is connected to the ground. So just know that this is where the ground is going. You understand? This side is the ground. You understand? This is a part for the ground, and you can even label it if you want. You understand? And if you want to put a terminal there, you can put it. But let's just keep this video very simple. Don't worry, I will still do extensive one very soon. So this is board outline. So we can now give it a border. So we can use that to know the size of our PCB. Click on the escape. So you can put this here now. So what are we trying to do? We are trying to use it as a measure. So this is what the size of our PCB is. Let me change this to millimeter. If I click on this now, this is what's this so called? So this is just the width is 13.3 millimeter by what's this so called? The height, yes, which is 9, let's say approximately 10. Let's just say 14 by 10 millimeter. You understand? Very, very small and portable. So let's shift everything together. So let's have what it looks like. You can see it very, very simple. So in case you want to do, you can add terminal, those places where you showed it and the rest too. But for now, we are just trying to understand how it works. So now I can come here, click on that part. If you put it, you are trying to put a place where the screw will pass through to the container. You understand? That is what we are trying to place. Then the other one here, the other one here. Boom. We are good to go. So now it must not touch this body. So let me adjust the body, the K cover again a bit. Okay. So this is what it looks like. The shape, you may decide to give it some, what's it so called? You may decide to give it a radius. Let's say I need it to be curved a bit. That's too much. This is 1. Yeah, that's perfect. So we want it to be curved a bit. So now another thing to look at is we've not routed. So it's good we really route our connection. So let's click on the routing. When you look at the routing, you come here. If you can do it manually, where you do the connection yourself. You can easily come and do the routing myself, but it can be stressful a bit. So the best way, just use the auto routing. You can see it here. Click on it, auto routing, to connect everything perfect. Let me zoom it so that you see your connection well. You can see, very, very neat, simple, and ABC. So just know your R2 is connected. You can see this is the ground there. So this is where your ground is connected to. This is where our power input comes in. Our audio input, that should be to this one, while the output is around this side. I will still show in the next video how you can connect all that terminals and the rest. But today I'm just trying to do a basic video to give you a breakdown of what this software is capable of. Remember, this is still the offline version. The online version can still do more. All right, so let's look further now. Let's now take it to a more interesting level. So go to, we've done with the routing. So now let's preview what it looks like. Go back to your project. Now this is PCB. This is what our schematic looks like. This is our schematic. That is what we convert to this PCB. Now let's view in 2D what it would look like in real life. To convert it now. You can see this is what the 2D looks like. You see that is very, very interesting, right? At least you're having a good idea. So this is what the hole and everything looks like. Now let's view it in 3D. 3D now. Hola. This is what a 3D looks like. You can see very, very interesting. Very interesting, very interesting. Don't worry. In the next video, we'll add some pin out where we'll connect the audio input, the output, the ground, and the rest. You understand? Today is just to keep it simple for you to just know how it works. And don't worry, I will still do a video where I will show you how to even create your own casing. Let me see if I can access that. Do I know what I used to save that? Where's that location? Okay, don't worry. Okay, there's a here recent, not in this place. Okay, so in that particular one, I will teach you. For example, you've built a PCB, and let's say we've attached all the various terminal, how to now create a casing for it in such a way that you can do the 3D casing for it, and this PCB will fit in perfectly. You will create all those various parts, and it will look more interesting. So if this video sounds very interesting to you, why not like, subscribe for more helpful videos like this. See you guys in my next video. Peace. Thank you for watching.